Hi everybody, welcome to my third part of my Unity3d tutorial series. In this video I'm going to talk more about transform component. So right now, if you look at it, we have a cube that moves back, forward, left, right, but I'm going to move it in a different way. So instead of you manually changing position, you can also use a method called translate. Transform dot translate. It says moves the transform in the direction and distance of translation. So it takes it has several overloads. There you can either enter a vector3 variable, which all vector3s in Unity has a x, y, and z components, and space relative to. So it can be moving in the world space or local space. We'll talk about it later. Or you can enter float values. And as you can see, I can go with the float because it's right here. But actually, I'm going to use a vector3 so you guys can see how vector3 works. I'm going to comment out these transform positions because we're actually manually changing them. Instead, I'm going to create a direction vector. Let's say direction equals new vector3. It's going to be a new vector3 object. If vector3 is just it's an object only has an x, y, and z values, so it's not that complicated. Don't let these names intimidate you. And I'm going to take the value of movement x for the x value. For y value, I'm going to leave it as 0 for now, but you could actually change the height of your direction depending on what you need later. And the movement z is going to be for the z value of this direction. Now here what I'm going to do is I'm going to normalize this direction. Actually, you know what? No, I'm not going to normalize it for now. So I'm going to enter direction. So my cube will move based on this vector3. And let's see how it's going to make things differently. As you can see, there's no change. It's still the same thing. It's just we're doing everything in one line instead of the previous two lines we had before. Now, I also want to cover the rotations. For example, what if I actually want my transform to rotate based on the x value and only move forward from the z value, right? So let's say horizontal, so we're not going to be actually moving the object on the x-axis. Instead, I'm going to enter 0 for the direction. And instead, I'm going to actually rotate the object from the value that comes from the horizontal axis. So transform dot rotate. Now, I want to rotate my object around y-axis, so it means that it's actually going to rotate from left to right or right to left. So 0f on the x-axis, movement x. Actually, I can change his name to rotate y. It would make more sense that way. Less confusion. Okay. And now let's check out the difference. It's compiling. Compilation is done. Now, if I press left or right, you see that the object is actually rotating instead of moving to left or right. But it's kind of rotating slowly. I'm going to add a different rotation speed. Rotate speed, let's say 40F. And I'm going to copy this and replace move speed with rotate speed here. And now let's try now and see what happens. And I can just rotate towards the direction and just move my cube there, right? I can even increase. By the way, any variable that you have for your class that is public as long as they're within certain types, they will actually show up in the inspector. So as you can see, player control is, this script is a component of the cube, and you can change these values from here. So instead of rotating 40, I can make it rotate 80 at the time. So with 80 speed. So it will rotate much faster. Okay. Also, the move speed can be changed. If I make it 100, it's going to go pretty fast now. Whoa. Yep. And let's leave it 10 to 100. Now, this is good if you're going to manually rotate your object. But now let's see how other objects rotate. If you want, let's say that there is another object that you want that object to watch your object. So let's maybe create a new script, and let's call it look at object. And I'm going to place this script to the main camera. As you can see, the main camera has a look at object, and I will use transform dot look at method. Now you can pass in either a transform object or you can pass in a vector3. So the way it's going to happen, I'm going to have a reference to my cube transform. So public transform player. Okay, so this will be referring to my cube, and I want this object that is carrying the script to look at my cube. Now let's go back to the editor. As soon as Unity compiles, you will see that a new field is here, player. I'm going to drag and drop my cube to that field. Now this script knows the player is my cube, and when we play, look at the camera, how the camera is going to move now. As my cube moves, the camera will move as well. So this is one way to do it. The problem with that is the look at is not a very smooth way to look at objects. For example, if let's say the camera is currently looking at the object, then I disable the script. Now it's not looking, right? And as soon as I click on look at, you see it just moved right there. It rotated so fast, it wasn't a good look. So instead, I'm gonna write a script that smooth rotates. Right. Let's create a new method here. Smooth rotate. Now, smooth rotate will actually use the direction vector. So vector3 direction. Now, the direction vector is going to be player position. So the position of the player, it's a vector3, right? It has an x, y, and z values, minus the transform that position, which is the position of the camera, because the script is attached to the camera, and the transform refers to the transform of the object that this script is attached to. This is an important one. Try to remember this one. And then we're gonna use a quaternion rotation. Quaternion rotation equals quaternion. So quaternion, what's a quaternion? Quaternions are variable types that are used to represent rotations. Okay, so if you rotate some object, for example, from looking this way and you rotate it this way, so this rotation here can be represented with a quaternion. Okay, so when it comes to rotations, you might need to use quaternions. Quaternion look rotation Direction will be go in there. So look rotation, it creates a rotation with the specified forward and upwards direction. So we're gonna enter the direction in here. Right. Now we're gonna update the rotation of my camera, but we also need to enter a rotation speed. Float, rotation, rotate speed. Let's say 20 for now, and we can change it later from the editor. Now we're gonna say transform dot rotation equals Quaternion dot slurp. Now the first rotation and the second rotation, so we're rotating from A to B, right? It's going to be transformed that rotation, and we're going to rotating the amount of rot here. So what's happening here is we're taking the difference between the positions that we find the position vector, the direction, and then we calculate how much you would need to rotate to be able to look at that position through this direction, and then we adjust our rotation based on that difference. And the float is going to be rotate speed multiplied by time delta time. And now the thing is, smooth rotate method needs to run inside the update method, otherwise it's not going, because it needs to be continuous movement. And I'm gonna remove the look at player function here. So now we're gonna have a smooth rotation instead of directly rotating. Actually, we can, you know what, we can do it this way. I'm gonna put a Boolean value here. Bool smooth rotate. And when I check this, when I make this true, it's gonna smooth rotate. If I don't check it, it's gonna just look at. Use the transform that look at. Else, okay. So let's see how this works. Now you can see that the camera is updated and there's a smooth rotate checkbox. It's a Boolean value. Now at the beginning it's just going to look. Right now if I move my cube, it's just looking at it, right? Now I will check the smooth rotate, and you see it's a very smooth movement. And I can make it, maybe I'll make this rotation slower. So you see object moves and the camera kind of follows it. And from there I'm just gonna switch back to look at. You see it looks awful. So that's the difference of how you look at objects and how you rotate, and rotating smoothly. Okay, and I'll see you guys in the next tutorial.